Hello, I'm Jeffrey Lawton, Product Marketer for Microchip Technologies Analog Division. Welcome to the first edition of ADC Aspects, a series of short discussions about the analog to digital converter. In this edition, we'll discuss quantization. The analog to digital converter, or ADC, is a device that provides a digital representation to an analog signal. Quantization refers to the process where an analog input value is mapped to a discrete level represented by a sequence of bits or digital code. The discrete values for a code level or quantization level are dictated by the input signal, voltage reference, and the resolution of the ADC. Since ADCs use a binary code, the number of levels an ADC can encode to is to the nth power. For example, a 3-bit ADC will provide 8 levels, and an 8-bit ADC will provide 256 levels. The magnitude of the analog signal difference between two consecutive code levels, or the minimum change in signal voltage required to guarantee a change in the output code level, is known as the least significant bit, or LSB. LSB is often used as a unit when describing ADC-DC characteristics such as linearity and offset error. For a better visual, we can look at the Adc Transfer Function. This LSB value is calculated from the ADC voltage reference divided by the number of levels. An alternative way that LSB may be presented is equated to the full scale range. Here, the full scale input range is divided by the number of levels minus 1. The subtraction of one level is needed as the ADC starts at the 0 input and the last code level reaches the full-scale value 1 LSB before the ADC's voltage reference. Thus, the LSB is dependent on both the ADC's voltage reference and resolution. With a 5-volt voltage reference, a 3-bit ADC would have an LSB of 625 millivolts, and an 8-bit ADC would have an LSB of 19.531 millivolts. An analog signal is a continuous signal with an infinite number of possible values, so it follows that there will be a rounding error if the analog input signal falls between quantization levels. This is known as a quantization error or quantization noise. From the Adc Transfer Function, we can see the inherent absolute error is going to be 1 LSB. The smaller the LSB, the smaller this error will be, and the closer we get to the ideal straight line. Additionally, ADC manufacturers will also introduce a negative half LSB offset to shift the transfer function to the left and shift the quantization error from range of -1 to 0 LSB to -1/2 to +1/2 in LSB, thus minimizing the maximum absolute quantization error to half an LSB. Thank you for joining me in this first edition of ADC Aspects. For more information on Microchip ADCs, please visit microchip.com/dataconverters. We'll see you next time.